Now that we've talked about angles and sides of a triangle, let's talk about congruent triangles. So if I introduce another triangle, remember congruent means that they are the exact same size and shape. The angles, as you can see, match up. Angle A is congruent to angle E, angle B with F, and angle C with G. And we also see that the side lengths match up. AB matches with EF, AC is congruent with EG, and BC is congruent with FG. And then we have our triangle congruence statement right here. Congruence also means it's a copy of each other, so I could take this, copy over. I could also rotate it or maybe flip it or slide it, but I still know that those angles and those corresponding sides still match up. It's kind of annoying though to have to check all three sides and all three angles to see if these triangles really are congruent. So today we're going to talk about some theorems that make it a little easier so we don't have to check all three sides and all three angles. All right, we got this set of triangles here. Notice that this side is congruent with this side because they have one tick mark each. This side is congruent with this side because they have two tick marks, and this one with this one because they have three tick marks. This is enough information to prove that they are congruent. This is one of our theorems. We call this side-side-side congruence, and we shorten that by SSS. And remember, each letter stands for a pair. So this is a pair of sides, that's 1S. This is a pair of sides, 1S, and this is a pair of sides, 1S. So I don't need to check the angles or anything like that because I have enough information here. 3 pairs of congruent sides is enough to prove that these triangles are congruent, even though it's rotated.
Now let's take a look at this set of triangles here. We can see that we have a pair of congruent sides here, we have congruent angles here, and then another pair of congruent sides. And so if we follow the same pattern here, we can name this one side, angle, side. And the key with this congruence theorem is that the angle has to be in between the two congruent sides. For example, if we had something that looked like this, we still have 2 pairs of congruent sides and an angle just like we had here, but notice how this angle is not in between these two sides. So this would not be side, angle, side. The angle has to be in between the 2 pairs of congruent sides.
Let's look at another theorem here. We got a pair of angles that are congruent, as we see with the 1 tick mark. We have a side here, indicated with the 1 tick mark through the side, that are congruent. And we also have this angle here, denoted with 3 tick marks to show that these angles are congruent. So remember when we are writing out our theorems that we want to have it flow. I don't want to jump around. So I got angle, side, angle. Because these pair of angles match, these pair of sides match, and these pair of angles also match. They're congruent with each other. Let's check out this pair of triangles here. Are these triangles congruent? Well, we see we have a pair of angles here that are congruent, another pair of angles, and a side here as well. Just like Emma mentioned with side, angle, side, the order of our letters matter. And because A is in between the 2 sides, that's why it's A is in between the 2 S's. And so here we got angle, angle, side, but the side is not included between the 2 angles. So we would write this as A, S. Because we have a pair of angles, and a pair of sides that correspond, but the side is not in between the 2 angles like it was on the last example we showed you where the side is in between the 2 angles, and so that's why the S is in between the 2 A's. But in this case, because the side is outside of the 2 angles, that's why we write it as AAS.
Let's take a look at this set of triangles here. If we notice, these are right triangles, and we can tell that because these squares here tell us that these are 90-degree angles. And a right triangle is created when we have a 90-degree angle. And another word that's important for us to understand is when we have a right triangle, the side length that is opposite of a right triangle is called the hypotenuse. And so in this triangle right here, this side is our hypotenuse, and this side is our hypotenuse. And the hypotenuse is always going to be our longest side. So the last theorem we want to talk about is the hypotenuse leg theorem. And this tells us that when we have 2 triangles that have congruent hypotenuses and a congruent side, or they call it a leg of a right triangle, they are congruent.
Now that we have our congruence theorems laid out, the most common way we apply these theorems is we're given 2 triangles and we want to see are they congruent. So here I have side LR is congruent with side AC. I have angle L here is congruent with angle A, and I have side LN is congruent with side AB. Looks like I have 2 pairs of congruent sides and the angle between them congruent, and because of that I know that this fits side, angle, side. So I would say triangle RLN is congruent to, I just want to make sure I finish my congruent statement by making sure they correspond. And we did talk about corresponding parts in the very first video, features and markings of polygons. So we got triangle RLN, and again the order of your first letters of your first triangle does not matter, just as long as the second one corresponds with the first part. So we got triangle RLN is congruent to triangle. R corresponds with C, L corresponds with A, since those are both the included angle, N corresponds with B. I could have written this in a different order, and that's okay, just as long as this also gets scrambled in the same way. So I now have my congruent statement. These triangles are congruent by side, angle, side congruency. On your derivative assignment, it might look like a side, an angle in between, and a side. It might have it written out instead of written shorthand.
All right, let's take a look at these two triangles here. The first thing I notice is that we have angle J, angle V, and they are congruent. All right, the next thing I notice is that we have two sides that are 16. So we know that WJ is congruent to VP. All right, and the last thing I notice is that we have side LJ is 12 and TP is also 12. So we know that LJ is congruent with TP. All right, so if we look at our first triangle here, we have a side, an angle in between, and another side. But if we come over to this triangle, we have a side, side, and then an angle. And so our angles and our sides don't correspond. We can't say that they are congruent because we don't have a congruence theorem that matches these.
All right, let's check out this set of triangles here. We got triangle MNP, and it's already telling us that it's congruent to triangle, and we just need to fill this in. Let's find our corresponding congruent sides. So MP matches with UV here because they're both 6. MN matches with UW because they are both 15 in length. I'm actually going to denote these with 1 tick mark and denote this with 2 tick marks. And then here NP is 12, so I'll do 3, and that matches with this 12 up here, which is 3. Since they already gave us the congruent statement, we have to follow this order. So M, if you can see, M has the 1 tick mark side coming out of it and the 2 tick mark side coming out of it, or the 6 and the 15. So I need to find the point on this side that has the 6 and the 15 coming out of it. So in this case, M corresponds with U. U has the 1 tick mark and the 2. So M and U match up. So I'd say this matches with triangle U. And then we have N is next. N here is 15 and 12, and that would be here would be W. And then my last one is P, and P would have to correspond with V because P has 6 and 12, and V also has 6 and 12 coming out of it. Triangle MNP is congruent to triangle UWV, and we know this is true because we have 3 pairs of corresponding congruent sides. So this would fall under side, side, side.
So let's take a look at these triangles right here. So this looks a little crazy because these triangles are connected, but if we remember back to our angle relationships video, there is a lot of things that we can find out about the angles and how they're related between these two triangles. Let's first look at angle X. We can see that line MZ intersects line NY at point X. From our angle relationships, we can say that this angle right here, angle MXN, is congruent to this angle, angle ZXY, by vertical angles, because when two lines intersect, the angles that are opposite of the intersection point are congruent by vertical angles. I'll denote this with 1 tick mark so we can remember that these are congruent. So we have 1 pair of congruent angles. The next thing we can see is that side length MX is congruent to side length ZX. So far we have a pair of congruent angles and a pair of congruent sides. So let's see if we can figure out another thing. Let's take a look at these two sides right here. They both have an arrow on them. And at first glance we might think, oh, perfect, these sides are congruent, we can use that. But these arrows don't mean congruence, they mean parallel. They mean that these two lines are never going to cross. If we think back to our angle relationships video, we can tell a lot of things when we have parallel lines that are cut by a transversal or by another line. One relationship that we can see is with angle M and angle Z. So if we extend these lines a little bit, we can see more clearly we have 2 parallel lines that are cut by a transversal. Angle M and angle Z are alternate interior angles, and we know that those are congruent. Angle M and angle Z are congruent because they are alternate interior angles, and I'll denote those with 2 tick marks so that we can distinguish them from these angles here. We have angle, side, angle. So we can say by angle, side, angle, these two triangles are congruent. So we'll have triangle NMX is congruent to triangle, and we know that angle N corresponds to angle Y, angle M corresponds to angle Z, and angle X corresponds to itself. So triangle NMX is congruent to triangle YZX by angle, side, angle.
I'm going to use this as our transversal through these parallel lines. What if we used NY as our transversal instead? Well, if we kind of tilt ourselves a little bit, we know that angle N would be considered alternate interior angles with angle Y. And I'll denote that with 3 tick marks to show that they're a different set of congruent angles. In this case, if I want to use N and Y instead of M and Z as my alternate interior angles pair, we see that we still have the same congruent statement, but now the theorem that applies is different because we have the side here, 6 and 6. We have these vertical angles here, and then we have these angles here. So notice that the side is not included or in between my two angles. So this time, if I'm going to use this as my transversal, I would say this is by angle side congruence because the side is outside of the two pairs of congruent angles. All right, let's check out this example here. We want to determine if triangle HEF and triangle FGH, are they congruent? We can see here that angle E and angle G are congruent because they each have that one tick mark there. We notice that we have parallel lines, just like Emma was saying in the last one. Just because we see parallel lines doesn't mean that EF and HG are the same size, but that can give us a clue for other angles that may be congruent. If we extend EF and HG here, and let's have FH be our transversal here, we can see here that angle EFH and angle GHF are alternate interior angles. And because these lines are parallel, we know that alternate interior angles will be congruent. So I'll mark them with 2 tick marks. Are there any other sides or angles we notice? Well, we know since these two angles match up with each other, then the third one therefore has to match up. But AAA isn't an option here. So let's look at sides. We don't know about these sides. We know these sides are parallel, but we see that FH and HF is the same line. So when they have a shared side, that actually counts as being a congruent side for one triangle and a congruent side for the other triangle. So we know FH is a congruent side. So we have angle, side, because the side is not included in between those two angles. So we can say our congruent statement is triangle EFH, and that is congruent with triangle. E corresponds with G, F corresponds with H on the other triangle, H corresponds with F. So we can say that these two triangles are congruent by angle, side congruency. Again, on your derivative assignment, it might look like an angle, and a side not included between the two triangles.
Let's look at these triangles here. We have triangle LGC and triangle LYC. And let's see if we can prove that they are congruent using one of these congruence theorems over here. Let's start by marking what we know is congruent. We can see here that because this angle has one tick mark and this angle has one tick mark, they are congruent. And then we can see that side YC is congruent to side GC because they have 2 tick marks. And then the last thing we can see is this shared side here. On our last example, we saw that when they have the same side, that is a congruent side. So LC is congruent to LC. So we will mark that with 3 tick marks since these ones have 2. We have an angle right here that's congruent, and then a side and another side. So over here, we don't have a congruence theorem that has an angle, a side, and a side. If you have 2 sides that are congruent in your triangles, the angle has to be in between those 2 sides in order for it to work. But because the angle is outside of these 2 sides, this is not enough information for us to say that these 2 triangles are congruent. On your derivative assignments, when you come to 2 triangles that you cannot prove based on one of these congruence theorems, they will say something like, this cannot be proved, and that would be the option that you would choose.
All right, let's check out this example here. We got triangle ADC, and we want to see, is that congruent to triangle ADB? All right, well, we can see here we got a tick mark here and a tick mark here, which means that AC and AB are congruent sides, so that is 1S going for us. We see here that this is a 90-degree angle, and because this is a straight angle, or supplementary angles, 90 plus 90 will complete our 180 degrees here. All right, so we can see here that this has to be 90 because 90 plus 90 adds up to 180 degrees. Okay, as Emma was showing us last time, we know that if they have a shared side here, AD is pair of congruent sides for both this triangle and this triangle. So we'll mark it with 2 tick marks to show that that is also a congruent side. So it looks like we got a side, an angle, and a side that are all matching. However, remember with side, the angle has to be in between the 2 sides for it to count. So if my congruent angle were up here, then that would count. But because it's down here, that doesn't quite work. In fact, it looks like ASS, which is not a valid condition. However, something that we do notice is that because these are right angles, we can see if HL qualifies here. HL, do we have a pair of hypotenuses that are congruent? Yes, we do. And do we have a leg or a different side of the right triangle that is congruent? And yes, AD qualifies. So we can say, even though it doesn't fit side angle side, they are still congruent by hypotenuse leg. So we'd say triangle ADB is congruent to triangle ADC by hypotenuse leg congruency.